In this lesson, we're going to look at kind of an introduction to chemistry and answer the question, how are bonds and energy related? So first off, what is a bond? So a bond is a sharing of electrons between atoms, and it takes energy to either make or break bonds. So here's an example, kind of a basic image of an atom, and we have the nucleus, and around the nucleus we have electrons, and these two electrons that are being shared between the atoms are what forms a bond. So next, let's look at what is a reaction. What's a chemical reaction? So this is when we either make or break or both bonds. And this is a little bit simplistic, but what I want you to think of is when we make bonds, we store energy. So energy is stored within that bond, and then when we break those bonds, we release that energy. So for example, we have here methane, which is natural gas, and oxygen. And methane and oxygen can be combined through the process, through a combustion reaction, and give carbon dioxide, water, and then heat. So we have broken bonds, we've rearranged them, and we've put them back together in such a way that they release energy. So why don't reactions just happen? The thing is that most reactions actually need some energy to get started. And we call this activation energy. If you activate something, you start it. So they need a little bit of energy to get themselves started. And this graph just shows how this works. So we start out, and if we add some energy, then we release a whole bunch of energy. So think about this kind of like a bonfire. The wood in the bonfire burns, but it doesn't just burn on its own. I have to throw a match in there to get it started. Once I add that little bit of energy, then the reaction will happen. So why is this important? It's important because having to add a little bit of energy to make a reaction happen allows living things to regulate their reactions. They don't happen just randomly. We can control when they happen so they don't happen when they're not supposed to. Think about what would happen if all of a sudden you just started sweating, or if your neurons in your brain just started firing, and those are things that are involved in many disorders. So an inability to regulate your reactions, life, at least complex life, just can't happen. Next, let's look at what a solution is. So a solution is when one substance is dissolved into another. And we have specific words for these. The solvent is the thing that does the dissolving. The solute is the thing that gets dissolved. So, for example, the salt is the solute and water is the solvent. One of the ways I remember this is you put in the solute. So you put the salt in, or the sugar, or whatever, and many people think of water as the universal solvent. Just think of like a solvent, like a cleaner or something like that, dissolves stuff or breaks it down. And now let's look at pH. So pH is a measure of how acidic or basic a solution is. And 0 is the most acidic. So something that has a pH of 0 is probably going to melt your skin. 7 is neutral. So water is right around neutral, depending. And then 14 is most basic. And again, if you touch something that's 14, you're going to get a chemical burn. Now, why is pH important? pH actually has a major effect on life. And your body uses a lot of energy in order to maintain a very specific pH. Now we're going to talk about this more later on, but if pH is not maintained through what we call homeostasis, you die very, very quickly. So it's extremely important for pH to be maintained. Otherwise, things within your body just don't work.